Alright, welcome to our first section in 2-1, graphing systems of equations. So in our very first example, we want to graph the system of equations of y equals 4x minus 2 and negative 16x plus 4y equals 12. Now, you might be thinking, like, what defines a system? And we just say it's this. It is two or more, I'll just put a little ellipsis there, two or more equations. So here I see I have two equations. It's a system. Now systems are useful because they help us basically model in Algebra 1 and Algebra 2 how two different phenomena interact with each other. So we're going to kind of review that here. Let's take a look at y equals 4x minus 2. We know that our b term is negative 2. So go down 1, 2, and put our very first point. We know that our slope can be written as 4 over 1, or our m term, and well, that means that we're going to count up 1, 2, 3, 4, and to the right 1. And we put our very first point. Remember, for graphing lines, I would typically like you to do 3 points. So from this second point, we go up 1, 2, 3, 4, and from here we go 1 to the right. And of course we can fill that in. And our graph should look something like this. Oh, I'll just broaden these points, but pretend Mr. Hastings can draw a straight line and it's actually touching. Okay, I'll tell you what, I'm actually going to switch to a different color here, and let's take a look at negative 16x plus 4y equals 12. Well, we know that in order to graph this, we must get y by itself. So we can start by, saying, hey, y is on the left of the equal sign. So let's add 16x to both sides. So plus 16x plus 16x. And you should recall that while those zero out and we have 4y is equal to 12 cannot combine with 16x. So I can write 16x plus 12. Now from here, to get the y by itself, we know all we have to do is divide every single term by 4. And so we have y equals 16 divided by 4 would of course give us 4x plus, and 12 divided by 4 would be 3. Let's see what that would look like. I'll go back over here to my y-axis at 3. Remember, that's our b term. And notice, I can definitely go up 4 and to the right 1 initially. I can go up 1, 2, 3, 4, and to the right 1. But I'm going to run out of room on my graph if I continue up. So let's go back to that initial point and let's do the exact opposite. Let's count down 1, 2, 3, 4, and to the left 1. Now you're going to notice something very interesting that you probably remember from Algebra 1. Imagining that Mr. Hastings was an artist and these lines were perfectly straight, would they ever touch? And the answer is no. So what do we call two lines that never intersect? And if you said parallel, well, you would be 100% correct. So these two lines are in fact parallel. Now graphically, what should we take away from here? We should take away this. Switch to a different color. Notice the slope here was 4 over 1, and notice here the slope was 4 over 1. So how can we define parallel lines? Well, graphically, they have the same slope. And that is the big idea. If you graph two lines and the number in front of the letter, the number in front of the x, if they're the same, the lines must be parallel. Pause that, and let's move on to our second example. Okay, let's go for our second example here, example 2. And just understand, I'm just asking you to graph these. Let's do something like this. Let's say, y is equal to negative 1/3 x plus 4. And our second system could be something like this. I'm trying to think here. Yeah, we could do this. Let's do negative 3x plus, let's do this. Let's do negative 9x plus 3y is equal to 6. Okay. Almost made a mistake, but I caught myself. So here we go. Here's our xy axis. Let's go ahead and graph our initial function. We see here our y-intercept is at positive 4, 1, 2, 3, 4, and I put my points. Here, let me use this same color for slope. I see that my slope is going to be negative 1 over 3, and so I will go down 1 and to the right 1, 2, 3, and there's my very next point. And of course, if I wanted to go down again, I could go down 1 and to the right 1, 2, 3, filling in my tick marks. And we now have enough information to graph our initial line. As always, please pretend that it is straight. Now from here, let's switch to a different color. Let's talk about our second equation. And by the way, I don't know if I said this earlier. Remember, we call it when x and y are on the same side. Standard form. That's a review from last lesson. Now how are we going to get this y by itself? Well, let's go ahead and add our 9x to both sides. And once we do that, I'm going to kind of shift it left just a little bit. We'll say 3y is equal to 9x plus 6. Now from here, we know we can divide both sides by 3. And by both sides, I mean every single term. That would be the best way to tackle this. And we'll get y equals 9 divided by 3, which is 3x, plus 6 divided by 3, which is 2. And let's go ahead and graph that. Oh, and by the way, make a prediction right now. Will these lines be parallel? Just yes or no. And make yourself a nice little prediction. So I go up to positive 2, and then let's say 3 is really 3 over 1, so I can go up 1, 2, 3, and to the right 1, and then from there I can go 1, 2, 3, and to the right 1. And wait a second, you're going to notice something here. These lines, they intersect, they cross. And not only do they intersect, not only do they cross at a right angle. So, what can we say here? Well, we're going to say this. We're going to say our very first slope, oh here, wrong color. We're going to say our very first slope, M1, was equal to negative 1 over 3. And our second slope was equal to 3 over 1. And what is special about these two things? Well, one, the fractions have been flipped. The first one is 1 over 3. The second one is 3 over 1. They've been flipped. So the very first property is that they are reciprocals. Okay? Also, notice this one is a negative and this one is a positive. They have opposite signs. So let's write that. They have opposite signs. And I think I might have just misspelled opposite. I'll look it up. But they are reciprocals with opposite signs. And what that means is they are in fact perpendicular. So if you notice two lines have opposite signs and they are reciprocals, they have to be perpendicular. If you notice the slopes are the same, they have to be parallel. Now, pause the video, finish taking your notes. This next example you probably won't need, but if you're a little unsure, let's just go for it. I'm going to show you an example where they are neither parallel nor perpendicular. So let's say something like this. Let's graph y is equal to 4x minus 3, and then let's go ahead and graph this one at 2x minus 3y is equal to 3. Okay, two very simple functions, and we're going to see, are these parallel, perpendicular, or neither? So let's go ahead and graph the first one. Here, I see that my b term is negative 3. I'm always labeling. So I go down 1, 2, 3, and put a point. I see my slope is 4 over 1. That's my m term, so I count up 1, 2, 3, 4 to the right 1. And again, I count up 1, 2, 3, 4, and to the right 1. Now from here, my very first line, draw it straight. Oh, there we go. It's going to look like this. And remember, when I switch this other color, I'm trying to get the y value by itself. So let's see. minus 2x minus 2x. You can say negative 3y is equal to negative 2x plus 3. And as I divide everything by negative 3, I'll get this. Y is equal to, a negative divided by negative is a positive 2/3 x, and a positive divided by negative is a negative 3 divided by 3 is a 1. And now I can graph my second line. It goes down 1, and then it'll go up 1, 2, and to the right 2, 3, and then it'll go up 1, 2, and to the right 1, 2, 3, fill in my tick marks. And you're going to notice something. Yes, these lines, they intersect, but they don't intersect at right angles, and therefore they are neither parallel or perpendicular. And we could have known that from the very beginning, because 4 over 1 and 2 over 3 are not the same, and they're not opposite reciprocals of each other. Alright, thank you so much, and I'll see you guys in our next section.